Okay, so this is going to be practice with critical points and using those critical points to determine increasing, decreasing, where the function is decreasing, decreasing, and maximums and minimas. So this question is going to be basically asking, find the local maxima and minima along with where the function is decreasing and increasing with this polynomial on 0 to 5. So when starting out these functions, the first thing that you need to do here is solve for x to find the actual critical points. And when you do that first, you have to actually solve the x for the derivative. So, that's not the derivative. So finding the derivative of this should be pretty easy. It's just going to be 3x squared minus 12x plus 9 plus 0. So what we're going to do is we're going to take what we have and basically just equal this to 0. And then we just do regular algebraic stuff where we factor this, and we can factor out of 3 here. X squared minus 4x plus 3. Alright, now we need to factor this, which is x plus x minus 3 and x plus 1, x minus 1. And this gives us critical points. It's x equals 3 and x equals 1. And 0 because of this. But 0 is already on our point, so it doesn't really matter. And then we're also going to count 5 as our critical point because it is, or because it could be a max or a minimum, whatever. So what we're going to do with this is first to find the maximas and minimas, the local maxes, local mins, we will be plugging it into our original function right here. So plugging each of these into our original function. So 3 to the third power minus 6 to the third power, times 3 to the second power plus 9 times 3 plus 2. Okay, so this is 3 times 3, 9, 27 minus 56, right? 9 times 5 is 45. Yeah. No. Okay. 54. So then we're going to do plus 18 plus 2. Let me calculate this. So 27 minus 54 plus 18 plus 2. So this first one is going to be negative 7. So it's going to be 3 at negative 7. And we basically just have to do that for the entire rest of this. So now we plug in 1 to the third, which is going to be 1 minus 6 times 1 to the second, which is again, this is going to be 6. So 6, or 1 minus 6 plus 9 times 1, 9 plus 2. So this is going to be negative 5 plus 9, 4. This is equal 6. So this is going to be 1, or 1 is going to be at 6. So 1 at 6. Now we move on to 0. So we have 0 minus 0 plus 0 plus 2 equals 2. So 0 at 2. Now I'll plug in our final one, which is 5. So 5 to the third power is 125 minus 6 times 5 to the second. Don't know 6 times 25 off the top of my head. 25 times 6, 150 plus, minus 150 plus 9 times 5, 45, that one I do know, plus 2 equals 125 minus 150 plus 45 plus 2. 22. Okay, so we have where our functions are at. So we find the minimum here, which is -7 in this situation, and then the maximum, which is 22. So our minimum, local min, or absolute min, whatever it's asking for, is 3 at -7. That's the point where our local min is at, or we'll have local min at. And then our local max, well, it's absolute max in this case because these are our only points, but anyway, is going to be 5 at 22. Hopefully I didn't do that math wrong. But anyway, that's the concept of this, even if I did get this wrong. So our concept is just whatever the highest one is, whatever lowest is, boom. If it's in a point though, it's going to be absolute. So I'm wrong here. It's not local. But so this is our absolute max right here, and our absolute min, and then this will, yeah, absolute max, absolute min. So that is how we find the mins and maxes with critical points. But what if it's asking for when is the function increasing and when is it decreasing? I'm actually going to check my math. See if I plugged all that stuff in correctly. +9. Oh, I did. Nice. Okay. Cool. So what I like to do when we have all of our values here is make a number line. So we have a line. We're going to plot our 0. We're going to plot our 1, and then our 3, and our 5. All right. So the next step here is we need to pick a point in between all of these. So this one, from 0 to 1 will be 1/2. From 1 to 3, 2. 3 to 5, 4. Cool. Cool. And now that we have our in-between points, it becomes pretty easy from here. Now we just need to plug it into our derived function. I was just checking if it was our derived function or regular function, but it's our derived function. So I'm going to go ahead and make some space here. Alright, now let's plug it into our, I just deleted the derived function. Did I? I didn't. Okay, cool. This is our derived function. Okay, so 3 times 1/2 squared minus 12x plus 9. I'll just write all this out right now. Oh, wow, I just didn't even. 1/2. So 3 times 2 minus 12 times 2 plus 9. And then 3 times 4 minus 12, 4 plus 9. Okay, now let's find out if it is increasing or decreasing on these. How do we do that, you ask? It's pretty easy. So we just need to find if this is a positive value or a negative value when we calculate this. So this right here, this will be 1/4. So 3/4 minus 6. 3/4 minus 6 is going to be fractions. I'm just going to put it in a calculator. 3/4 minus, pretty sure this is positive, plus 9. Yeah, it's 3.75. So this is going to be positive, meaning that this whole section here is positive. This one right here is going to be 6 minus 24 plus 9. So 6 minus 24 is -18, plus 9 is -9. So this one's negative. So this section right here, negative. This section, 12 minus 48 plus 9 is another negative. see, I don't even have to compute this. I just know that this is going to be negative. So this is also a negative. So that means that the function from 0 to 1 increasing due to the positive, and then from 1 to 5, or you can make it 1 to 3 and 3 to 5, is decreasing. And you can plot that as well on a little graph here. This is 0, 1, 3, 5. So from 0 to 1, increasing, increasing, increasing. 1, that's where, that's where the changes. Decreasing, 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 all the way to 5. So that's the basic point of critical points, increasing, decreasing. That's all that I really need to know for now. And yeah, the number line thing helps. Whatever helps. That's pretty much it. So, oops. Yeah. All right. I'm just gonna get rid of all this. Okay, cool.